2.5 model direct variation. So overall, this stuff is very easy, but people tend to mix it up and get confused with it. All right, so it says to write and graph a direct variation equation that has the given ordered pair as a solution. So -3, 12 is the ordered pair. For direct variation, our equation is y is equal to ax. So we have to initially solve for a, and then we have like a y equals some number and then x, and that's our equation that we would graph. So 12 is equal to a times -3. So a is equal to -4. And then we just plug that back into that equation, y equals -4x. So that's our direct variation equation. And then I'm only going to graph one of these because I know y'all know how to graph. So we have y-intercept at 0. I guess I should put so it goes down 4, right 1, up 4, back 1, and just connect. So for the sake of your homework, I don't really care if you graph them since I know y'all know how to graph, but on the quiz or test, I may ask you to graph them. So just make sure you know how to do that. Are we okay with that type? Okay. We'll be doing more that basically does that. It just adds another step to it. So I figure we'll just jump down to those. All right, so as the variables x and y vary directly, write an equation that relates x and y, then find y when x is equal to 12. Okay, so there's going to be two answers that you need to have for these. So 12 says x is equal to -3, y is equal to -5. So the first thing we need to do is we need to figure out what a is equal to. Okay, and get our direct variation equation. So y equals ax. So then -5 is equal to a times -3. So a equals 5/3. So a lot of times people stop there and think that's sufficient. That's not the direct variation equation. So if you don't have y equals 5/3 times x as your first part, you're not completely right. So that's part 1. Then it says it wants us to do it or solve this then for y when x is equal to 12. So then I just plug in 12. So y equals 5/3 times 12. And that ends up being 20. Okay, so make sure you have both pieces or it won't be completely correct. And I say that because every year people don't do that. It's what was given to you in the problem. The instructions say, then find y when x is 12. All right, I'll do another one like that. 16, x is equal to 2/3, y is equal to -10. So y equals ax. And you don't have to write that every time. I'm just writing it right now so that you hear it over and over again so that you know what the form is. So negative 10 is equal to a times 2 over 3. So I'm going to multiply by the reciprocal of that fraction. So that's going to end up being, do this just so I can visually see it. So that's going to be negative 15 is equal to a. So y equals negative 15x. So there's part 1. So part 2, we're doing it for x is equal to 12. So y equals negative 15 times 12. Anybody know what that is? Nope. It's higher.
160.
Higher. Negative 180. I knew we'd get there eventually. All right. We okay with that type? All right. Tell whether the equation represents direct variation. If so, give the constant of variation. So 23y minus 7 equals 10x. So for something to be direct variation, it has to be able to be written in the form y equals ax. Okay? Can't have a plus or a minus anything, blah, 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 whatever. With this problem, though, to begin with, okay, it doesn't look like direct variation. Okay, and I'm not saying it is or isn't yet, but it doesn't look like it because it's not in y equals ax. Okay, so I need to move stuff over and get y by itself and then decide if it's direct variation or not. So I would add the 7, so 10x plus 7, divide by 3, so y equals 10 over 3x plus 7 over 3. So now I can say, is this direct variation or not? No, why not?
Because you can have anything added as you weight this.
Right. Not direct variation because of that right there. Let's do one more of those. 22, 5y is equal to negative 4x. So I need to get y by itself. So y equals negative 4 over 5x. So this is direct variation, yep. And what would the constant of variation be? Constant of variation is a. Yep, negative 4 over 5. So if it is direct variation, make sure you state what the constant of variation is. Since y'all were good with 12 and 16, 24 through 29 are the exact same thing, except for they give you a different y value to plug in. So just make sure you pay attention to what the y value is that you're plugging in the problems. I'll skip that. And then let's see. All right. The last ones give you a table of data, and it says to show if it's direct variation or not, and if it is, write an equation relating x and y. So 32. So we have for x, we have 1, 2, 3, 4, 5. For y, we have 7, 9, 11, 13, and 15. Huh?
Same thing as whatever it was last.
Well, so kind of, but we're going to see if we have direct variation or not. So we're going to test. This is the 0.17. So we're going to plug in for x and y, and we're going to see what a is. A should be the same across every point if it is direct variation. So 7 equals a times 1. So a is equal to 7 in that case. And then I'm going to do 3 and 11. So then if I plug in 11 is equal to a times 3. Divide by that. 11 over 3 is equal to a. Those are not the same, so this is not direct variation. So all you need to do really is check 2 of them. You don't need to ever check all 5 of them. If 2 of them work, assume it works. So, and if at any point they're different, then obviously it doesn't work. So, and if it had worked, you would need to rewrite the equation with a in. So you would need to have y is equal to whatever a was, and then x to actually give the equation for it. Any questions on that? Or do we need to see another one? Are we okay? Everybody good? All right, your problems then are 3, 11, 13, 19, 21, 25, and 33, which 33 is a table one, just like this one.